Hello, this is section 6.3, systems of the linear equation in three variables. So since we are using the three variables, we have to use the spaces. So we are using the three different the variables in the as a three equation as a system. So basic concept, the solution to a system of the linear equation in three variable is order triple. So which is you get the x and y and z as a system. System of the linear equation can have a 0, 1, or infinitely many solution. It's the same as two variables too. Okay, so we want to determine that the order triples are the solution. Okay, so let's check with the first one. So first one you have -1 and 2 and 2. So in order to be the order triples is a solution, it has to satisfy all the system of the equation. So yeah, when you once doesn't satisfy the one of the equation, we can call that as a solution. So starting with the equation 1 and 2 and 3. So equation 1, I plug it in as x plus y minus 2 times of z equal to -3, and then I want to check that the left hand side is also equal to -3. Okay, so -1 plus 2 minus 4 negative, oh yeah, -3 equal to -3. So yeah, it works for the equation 1. Equation 2, 2 times of x minus y minus 3 times of z is equal to -9. So -2 minus 2, -6. But I noticed that this is a -10, which is not equal to -9. So it doesn't work with the equation 2. So I want to say this is not a solution as a system. All right, let's check with 1 and 2 and 3. So same way. So equation 1, x plus y minus 2 times z isn't equal to -3. So, x is 1. What am I doing here? So x is 1, okay. So 1 plus 2 minus 6 equal to -3. Yes, it is. -3 equal to -2. So it works for the equation 1. Now the equation 2, 2 times of x minus y minus 3 times of z is equal to -9. So 2 minus 2 minus 9 equal to -9. Yes, it is. So check for equation 2. So equation 3. You got negative x plus y plus 4 times z is equal to 13. 1 plus 12 equal to 13. Yes, it is. 13 equal to 13. So it works for the equation 3 too. So 1 and 2 and 3 are the point on this three linear equation, which is the solution of the equation. So this is a solution this time. Okay. All right. Solving the system of the linear equation in three variables. Step 1. Eliminate one of the variables such as x from the two of the equations. And step 2, apply the technique discussed in the first section in this chapter to solve the two resulting equation in two variables from the step 1. If the x is eliminated, then solve this equation to find y and z first. And the step 3, is there no solution for y and z, then the given system has no solution. So if there are infinitely many solutions for the y and z, then the y in terms of z and proceed the step 3. So step 4, substitute the value of the values for y and z in one of the given equation to find x, and the solution is going to be x and y is in order. And check your answer as example 1. Alright, let's go to the first page and the next page to solving the equation. Okay, so I labeled each equation as a number 1 and 2 and 3. So what I want to do is, I think I want to eliminate the x. Okay, so what I do is, I am going to add equation 1 and 2 together. So x plus y minus 2z equals to 3. Negative x minus y plus 3z equal to -1. Add them up. X cancel, y cancel, z equal to 2. So we got the solution for z already. Alright, now I want to eliminate the x again. So this time I want to add equation 2 and 3. So negative x minus y plus 3z equal to -1. x plus 2y plus z equal to 12. So I'm adding it up. And then y plus 4z equal to 11. But since we know the z, so I'm going to plug it in the z as 2 for y. So plus 8 equal to 11. And subtract the 8 both sides. And then I got 3 for y's. And then in order to find the x, you can use any of the equation, but I want to use the equation 1. So equation 1 to solve for x. So x plus y and 2 times of z equal to 3. So x plus 3 minus 4 equal to 3. X minus 1 equal to 3. Add 1 both sides. X equal to 4. So now you need to put the order triple. Okay, so x, y, and z. Alright, so this is the solutions. Now what you do is you need to plug back into the equation to make sure that this is the solutions. Okay. Alright, next example. Now we have a word problem, which is we can set up as a system of the linear equation. Okay, so 1,000 tickets were sold for a total of the $15,500, and the price of the tickets were $10 for children, $15 for students, and $20 for the others. There were 1,200 more student tickets sold than the other tickets. So find the number of each type of the tickets sold. Okay, so first of all, we need to actually define the variable. So I want to say let x be the number of children's tickets sold. And then I want to say y is the number of student tickets sold. And then last letter z, then I want to say this is going to be the number of others ticket sold. Okay, so we have a x and y and z. Okay, so number of the total tickets sold is gonna be the 1,000, right? So I want to say x plus y plus z equal to 1,000. Sorry. So this is equation 1. And then also the total price of the tickets are the 15,500, right? So the children tickets are $10, and student tickets are $15, and other tickets are $20. Okay, and then it makes a 15,500. So that's equation 2 for the price of the total tickets. Okay. And also, there were 200 more student tickets sold than the other tickets. So the difference between the number of the ticket from the students and others are 200. So you can say y minus z equal to 200. So this is equation 3. Okay, so now what I want to do is, okay, I need to eliminate the x terms, okay? Because equation 3 only has a y and z, so if I eliminate the x terms, and then I don't need to create another equation. So what I want to do is, I like to multiply equation by, sorry. I like to multiply equation 1 by the negative 10. So which means I'm going to multiply by negative 10 here. Which I have negative 10x minus 10y, negative 10z equal to negative 10,000. Okay, so this is the equation 1 prime. And then I'm going to put the equation 2 together, which is a 15,500. And then I want to add it up. So x cancel, which is a 5y plus 10z equal to 5,500. So I want to call this as equation 4. Now, I'm going to multiply the equation 3 by negative 5. Or, oh yeah, you know what? Okay, I'll do something else, okay? I want to multiply equation 3 by 10. That's actually the better. Because these are already negative z, right? So what I do is, I'm going to multiply by 10. So I got 10y minus 10z equal to the 2000. So I got 15y equal to 7500. And then divide by 15 both sides. So y equal to, so 7500. And divide by 15 is, okay, so 500. So 500, the student tickets. Now we still need to find then the x and z. So I think I want to find the z first. Okay, so I'm gonna bring down the equation 3, which is y minus z equal to 200, and then y is a 500, and then so for z, and then z equal to negative 300, negative 3z, right? So z equal to 300. So 300 means that's the number of the other tickets. And then together, for the 3 different tickets gonna be the 1000. So I'm gonna use the equation 1, which is x plus y plus z equal to 1000. So x equal to 1000 minus 800. So x equal to 200, okay? So now we had it, right? So there'll be how many? 200 children tickets. And then 500 students tickets. And then 300 other tickets. Sold, okay? So yeah, so this is all. Alright, let's look at the next one. Now, alright, 3 students buy lunch in cafeteria. 1 student buy 1 sandwich and 2 soda and 3 candy bars for $9. Another student buy 2 sandwiches, 1 soda, and 1 candy bar for $9. And then the third student buys a soda and candy bar for the $4. If possible, find the cost of each items. Okay, so I'm gonna say let x is the cost of. Okay, I think it's a 2 thing. Sorry. Let me use this one. Let x is the cost of a sandwich, and then y is the cost of a soda, and z is the cost of a candy bar. All right, so 1 student buy the 1 sandwich and 2 soda and 2 candy bars, which makes it $9. And then because the x and y is already the cost, okay? And then second student has 2 sandwiches, 1 soda, and 1 candy bar, which equal to $9. And then third student has 1 soda and 1 candy bar, which makes it $4, okay? So equation 1, equation 2, equation 3. All right, the same thing. I want to eliminate the x to use the y plus z, which is equation 3, to combine them together, okay? So what I want to do is, I think I want to multiply negative 2 to equation 1, which means if you multiply negative 2 here, and then they'll eliminate the x terms, okay? So you get negative 2x minus 4y minus 4z equal to 18, which is a negative 18. Okay, and then you got 2x plus y plus z equal to 9. So add them up. So you got negative 3y minus negative 3z equal to negative 9. Okay, so if you do this, I think this, I'm gonna call this equation 4, but I think I can divide by 3. So if I divide by 3, and then I get negative y minus z equal to negative 3, which is a 4 prime. And then I can put the equation 3 together. And then if I add them up, what happens is 0 equal to 1, which is not true. So that means this combination never works. So we have to say no solution for this case, okay? So this doesn't make sense. All right, okay, equation 5, the example 5. Now we are solving another equation. So we have like a one solution case and then no solution case. So let's see what kind of types we're gonna get from here. So the same thing. I think I want to eliminate the x terms from the equation 1 and 2. So before that, I'm going to multiply negative 2 here. If I multiply by negative 2, I got negative 2x minus 4y plus 2z equal to negative 4. The 2x minus y plus z equal to 2. And then that's equation 1 and equation 2 together. Oops. And then x term cancel, negative 5y plus 3z equal to negative 2, which is equation 4. And then I put the equation 3 together. And then add them up. And then what happened is everything cancel equal to 0. So which is true. Because of that, this equation the same equation. So we have to say there are infinitely many solutions, okay? Alrighty. Okay, so that's all. Thank you for listening.